Alrighty, Miss Whitaker here, and we are in that home stretch heading towards STAAR. So this past few days and over the next week, we will be preparing for the STAAR test coming up a week from Tuesday. But I do want to go over this 30-question diagnostic that I gave you as a sort of review. What I'm gathering from just observations on the STAAR test so far, that the STAAR will probably be a little bit harder than this, will probably be more detailed and probably more concepts per question. Now remember, as we discussed in class, you'll see an R or an S next to the questions on this diagnostic, and that stands for readiness standard versus supporting standard. Readiness standards will make up 2/3 of the STAAR test, and the remaining third of the test will be the supporting standards, and there's a lot less readiness standards than there are supporting. So what they're saying, the state is saying, there's just a fewer standards that we really want to go deeper with, and then there's some that you've already mastered or will master next year, but the readiness standards are the ones you need to really have a good grasp on in 7th grade. So let's go over these questions, and please take notes as we go. Let this be a good review for you, and make sure you circle ones that you want to ask me about or get more practice with. All right, number 1, which of the following statements is true? So we're looking for one that's true, so we want to make sure that sticks out to us. This is a supporting standard, so it's not one of the readiness standards I'm talking about, but this is pretty much just ordering decimals. So you should be able to do that. What I'm going to do is, I noticed that there are, in most of these, there's 3 decimals involved here. C had one that was a little different. So I'm going to put these, and the way I'm going to order these is line up my decimals. And that way, when I compare these decimals, I'm looking at a place value at a time. And the first time that comes to there's a difference in the place value is this one right here. And the 2 is bigger, and so that automatically makes this the greatest number, and then I go to the next digit, which this one would be the next one, so that's the middle value, and then this one is the least amount. So I have my highest number is 1.02. So if I need to make sure that I have a statement that says that 1.02 is the biggest one. And the other thing we have going here in this problem is understanding these symbols. Make sure you know that this symbol right here means less than, and you read it that way. This symbol means greater than. So make sure, I know you've learned something about alligators or crocodiles or whatever, but we really need to get to a point where you can recognize this symbol right here and see it as less than, and this symbol as greater than. You would read it that way. So what A says is 1.02 is less than 1.004, and we just discovered that it's greater than. So this is going to disqualify that from being a true statement. So A can't be true. 1.02 is greater than 1.004. That's true. And 1.004 is greater than 1.0. This is a true statement. I think that's true. So I'm going to check my other answer choices. This says that 1.006, and I don't know if this was a typo or if this was on purpose, but they have one less zero in this one. But anyway, this is still going to be less than 1.02. So that's wrong. So that's going to be ruled out. And then 1.0006 is not greater than, it's less than 1.004 and less than 1.02. So the alligator is open to the bigger number. Make sure you know that, and make sure you know those symbols. So I know B is right, and I know that would be a smiley face, but that's just ordering decimals. Please don't miss those. We want to shoot for commended on this test, so we want to make sure we get the readiness standards as well as the supporting. So make sure you know how to order decimals, line them up, compare a place value at a time, and make sure you know the symbols. All right, let's move to number 2. Number 2 is a readiness standard. This is converting between fraction, decimal, percents. It looks like all of the whole numbers are 11. They're all the same. So really what I'm looking at is just the 0.6. So I need to know how to change a decimal to a fraction. Decimal to a fraction, which is often one that people forget. Decimal to fraction is I'm going to look at the last digit. The last digit's place value is going to be the denominator. And then I reduce. So this last digit, there's only one digit. What place value is that in? It's in the tenths place. So this is the same thing as 6/10, and that's how I would say that. 0.6 is 6/10. Then that can be reduced to 3/5. They're both divisible by 2. And I get 3/5. So this 11.6 is the same thing as 11 and 3/5. It's 6/10, not 6/11. 1/6 is less than half, and I know that 0.6 is greater than half, and 1/11 is less than half. So I've looked at all my answer choices, and I've evaluated. I know I have the answer, and I know that this is a smiley face because I looked at all the answer choices. Make sure you know how to convert. Decimal to fraction we've talked about. Fraction to decimal is top in, bottom out. And then we've got decimal to percent, 2 to the right. Move the decimal 2 to the right. And then percent to decimal, same, go 2 to the left. And then we've got fraction to percent. Fraction to percent. We can do top in, bottom out, change to decimal, and then change it to a percent. Or we can get a fraction, an equivalent fraction, over 100. As the denominator. And then we've got percent to fraction, put it over 100, and then reduce. So just make sure you know how to do all these conversions. This is a huge concept for 7th grade math, so just make sure that you're good on this kind of a problem, on converting back and forth, an equivalency. Use common sense. Is it less than a half or greater than a half? It should be about the same. Well, not about the same. It should be exactly the same. So be using the halfway as a benchmark for yourself, and just really think hard on these, because you are going to see quite a few problems just on this one concept right here on this readiness standard. All right, number 3. Moving a little faster. It costs $6.75 to get into an amusement park, $2.15 for each ride. I'm going to say $6.75 to get in plus $2.15, and I'm going to say R for ride. So $2.15 a ride. So if you're going to go on 8 rides, then you're going to do $6.75 to get in, and then 2.15 times 8. So we're going to do that first. $2.15 times 8. That's $17.20. We move it. We only had 2 place values, so we move it twice from the right. $17.20, which makes sense. I mean, $172 doesn't make sense. $1,000 doesn't make sense. $1.72 doesn't make sense. So $17.20 makes sense. Then we add that to the $6.75, and I line up my decimals when I add or subtract, and that gives me 95, 23.95. Now I'm thinking on C and D, you better just stay home because that's too much for an amusement park. And this is just for the rides. So look at all your answer choices. That's just too much. look at all your answer choices and choose wisely. This is also considered a readiness standard, so we're talking about equations and dealing with decimals as well. All right, number 4. If you have the following chips, which equation would you use to find the total score? I see 7 positives here, I see 7 positives here, and I see 7 negatives there. And then I look at my answer choices. I've got 3 negatives here, and that's not, these are not equivalent to negative 21, so that's not it. These are 3 sets of positive 7, and that equals positive 21, and that's not reflected up there either. This has 2 positive 7s and 1 negative 7, which I do have up there, and I want to see if it equals 7. Now remember that a positive 7 and a negative 7 wash each other out, so that just leaves me with that positive 7. And if I did keep, change, change on D, I would do keep, change, change. That would be 7 plus 7 plus 7 again, and that's not what I have. So I'm pretty comfortable with my answer of C, and that's a supporting standard. All right, number 5 is another supporting standard, and this has to do with your distance formula of rate times time. So 33 miles in 6 hours. So we're given the distance and we're given the time. We're looking for the rate. So if we use this formula, we plug in what we know, 33 miles, and it was 6 hours times R. So 6 times what equals 33? To isolate my variable, I can divide both sides by 6. So I just need 33 divided by 6, which is 5. Now I'm left with a remainder. And when I have a remainder, I can add a decimal and a 0. I don't need to put R3 anymore. That's elementary school. Now we just keep adding decimals and keep adding zeros till we have no remainder. And then I can do that, and I'm done. No remainder. So 5.5 is my answer. And then just go back and plug it in and check it and make sure. The average speed in miles per hour, she's walking. Remember, she's walking. I don't think she's going 198 miles per hour. I mean, really? Come on. And then 33, no. And 2/11ths of a mile per hour, that's kind of silly too. So please make sure you're checking for common sense as well. Remember, she's walking. Make sure you understand what's going on in the question. All right, number 6 is another supporting standard. This is just order of operations. You should have already mastered this. This is PEMDAS. So I'm going to write out 2 times 3 squared plus 5 times 4. First thing is parentheses, and I don't have any. So next one is exponents. I'm going to do this one first. So that's 9. 3 squared means 3 times 3, which is 9. And then I'm going to rewrite everything. Next one would be multiply and divide from left to right. And so this one's the first one I come to. That's going to be 18 plus 5 times 4. Then I'm not done with multiply. I'm going to do my 20 here. And then I'm going to do my last 38 is my answer. Go ahead and do it twice just to be sure. But just make sure you do PEMDAS order, parentheses first, everything in parentheses, exponents second, multiply and divide from left to right, and then adding and subtracting from left to right. So just make sure you're able to do those PEMDAS questions and go in order. You know there's going to be answer choices of going in different orders, so make sure you're going in the right order to get the right answer. All right, number 7 is another supporting standard. It says there are 2,913 seats in a theater. The seats are divided into 3 sections, orchestra, mezzanine, and balcony. How many seats are in each section if there are the same number of seats in each same number of seats in each section? So I'm just going to take the total seats and divide by 3 if there's the same amount in each. So 2913, obviously this is supporting. This is something you should have mastered quite a few years ago. 3 into 29 will go 9 times. That's 27. Bring down the 2 and then the 1. 3 into 21 is 7. 7 times 3 is 21. Then I need to bring down the 3. 3 into 3 is 1, so 971. Then go back and check. 971 times the 3 sections should give you your 2913, okay? Make sure you check. All right, let's look at number 8. It says the 30% discount Justin received on a coat amounted to 15, and I also noticed on number 8, this is a readiness standard. This is something we really need to remember. We haven't done this in a while, percentages, but I think you'll remember now that we do this, which is really good, just in time for STAAR. The 30% discount received on a coat amounted to 15. So 30% discount was $15 on this coat. What was the price of the coat before the discount? So I'm looking for the total, the full price before he got the discount. So remember, our percent over 100 equals is over of, or part of the whole. So let's write that down. Whenever we have a percentage problem, it's usually this formula is probably the one we're looking at. The percentage is 30, so 30 over 100, and then the other number was 15. Now what's the 15? Does that go with the 30% or does that go with the full price? The $15 went with the 30%. That $15 was equal to the 30%. So the 15 goes on top. And what I'm looking for was the 100%. What was the full price? So I can do a couple things here. I can notice that 30 to 15 is divided by 2, and then I can divide the 100 by 2. Or I can do cross products, 1500 divided by 30. Either way, this is, remember that a proportion is going to be 2 equivalent ratios. So these are going to be equivalent fractions. So I can work it out either way. They're going to be equivalent to each other. So either way, I know x is 50. Then just go back. What's 30% of 50? I can do 10% of 50, which is 5. Do that 3 times. That's $15. Okay. Please be familiar with that percentage formula. You may want to circle that, and we'll come to it. All right, let me shrink this down a little bit. All right, number 9, a map of Sarasota Middle School uses a scale of 3/4 of an inch to equals 1 foot. The library shown on the map is 22.5 inches long. What's the actual length of the library? So this is a proportion problem. It says 3/4 of an inch is equal to 1 foot. How much is 22.5 inches in feet? So this is how we set up our proportion. Now, because I don't like fractions and fractions, I can change these easily to decimals. So why don't we go ahead and do that? 0.75. Let me move that up here. 0.75 and 22.5. So 0.75 and 22.5 up here. Now, I know this is just going to be 22.5. So now I can just do 22.5 divided by 0.75. Let's see. Let's just do that right here. Now remember, when I'm dividing decimals, I can't have a decimal on the outside on my dividend. So I'm going to have to move that, my divisor, sorry, and then move that to the end. And if I moved it on the outside, I got to move it on the inside. So that makes sure your answer makes sense. 75 into 225 will go, I believe, exactly 3 times. Then I have 0, so that's going to end up being a 0. So that's going to be 30. And then just go back and check. 30 times 0.75 will give you the 22.5. Let me think how we can see this. If 3/4, okay, this makes some sense. If 3/4 of an inch is 1 foot, 3/4 of an inch is equal to 1 foot. Then if I have 22.5 inches, neither one of these really make any sense. And this one probably doesn't either, just because 3/4 represents 1 foot. 22.5 is going to be substantially bigger than that. So make sure you go back and think about, well, if 3/4 of an inch is 1 foot, then 22.5 inches is not going to be less than 22.5 feet. So keep that in mind and reflect on your answers. But this is a proportion problem, so set up your proportion like this and use cross products to solve. All right, and number 10, which expression can be used to find the value of the nth term in the table? Now remember, nth term, n is the position, please write that down. N is the position of it, and they have the position right here. So here's our n row right here. And so I'm looking for, how am I getting from the position, the number of the position, to the actual value that's sitting there? From 1 to the 1, from the 2 to the 1.5, from the 3 to the 2, from the 4 to the 2.5, from the 5 to the 3. So what does my value that sits in the position have to do with the position where it sits? I know that sounds confusing, but we're looking at a sequence to see the numbers, the terms in the sequence, and how they relate to its position. So let's check each answer choice here. N minus 2. So the first position should be a -1, because 1 minus 2 is a -1. The second position should be a 0, and I'm not seeing that here, so I can pretty quickly rule out A. All right, n squared. 1 squared would be 1, so that looks right. 2 squared, though, would be 4. 3 squared would be 9, and I'm not seeing that up there, so that's gone too. All right, 2n plus 2. If I plug in the first position should be a 4, and I don't see that up there. It better be D. N divided by 2 plus a half. 1 divided by 2 is a half, plus a half equals 1. Second position, 2 divided by 2 is 1, plus 0.5 is 1.5. And then the third position would be 1.5 plus 0.5 would be 2. And I'm starting to see that, so I'm pretty comfortable with my answer. I've ruled out the others anyway. So don't forget this. N is the position, and I'm looking to see what is the relationship between a number that sits in a sequence and the position where it sits. So don't forget that. So that is also, let me make sure I've got that. Oh, that's a supporting standard, but we should know how to do that. That's an easy one. Just look at all the answer choices and see which one works. Don't forget what N is. All right, number 11. Look at the following key. Just look at it. Square is -1. Circle, +1. Which of the following shows an accurate equation using the symbols? So I'm looking for true. This would reflect a -6 on A and then a +2. A -6 plus 2, what would that be? It'd be a -4. But that's not a -4, that says a -2, so that's not equal. All right, -6 plus a +2, it gives me a -4, so this is right. I'm thinking this is it, but I'm just going to come back to it. This says a -3 plus a +5 should give me a +2, and that's not a +2, so that's not it. This says -3 and a +5 should give me a +2. This says -2, so that's not it either. I'm good, absolutely positive. Number 11, and number 11 is also a supporting standard. So make sure you understand the key. Work out the math. You see the work I'm doing? I'm doing the math that it takes to get the right answer. We're not guessing on any of these. All right, number 12. Admission to a movie costs $6 and a single bag of popcorn costs $4. If Y is the total cost and X is the number of people, which of the equations below can be used to calculate the total cost for a group of friends to go to the movie and share a single bag of popcorn? All right, so a single bag of popcorn is going to be $4. And then we have $6 a person to get in. So $6 a person to get in, plus the $4 popcorn that they're going to share. And that is reflected in D. This says $4 a person to get in and $6 popcorn. Nope, that's not it. $4 a person, so $4 is out immediately. And the difference in here is that why would I, if Y is the total cost, why would I subtract the cost of the popcorn from how much they paid to get in? So I don't need to do that. So I'm looking for y being the cost, the total cost. So I need to add up all those costs right there. All right, number 13. Number 12, by the way, is a readiness standard. So please make sure you can take a scenario and interpret it and translate it into a math problem, into an equation. Number 13 is also a readiness standard. Phil is running a 26-mile marathon. If he has already run y miles, which equation will give x, the number of miles he still needs to run? So x is the total of the marathon. Take away the number of miles he's already run. This is reflected in A, and I'm not going to take the 26 total miles and add what he's run. Don't need to do that because x is what he still needs to get. We're not talking about y being the total miles of 26 plus x, and it's not D either. So make sure you are taking a scenario and you can turn it into an equation that makes the most sense. Number 14, a rhombus. This is a supporting standard. A rhombus is a quadrilateral in which all the sides are of equal length. Wow, they even told you what it was. You didn't have to remember. Remember, it could look like a slanted square, but a square is a rhombus because it has all equal sides. It says, which of the following polygons must be a rhombus? Does a parallelogram have to be a rhombus? No, it doesn't. It could look like a rectangle, and that's not all sides equal. A regular polygon, let's see, all sides equal, regular polygon. Oh, a rhombus is a quadrilateral, so a polygon doesn't have to be a quadrilateral. So it doesn't have to be that one either. And then an equilateral triangle is not a quadrilateral. So a square is the only thing. All sides are equal in a square, and that's your condition for a rhombus. All sides have to be equal, and it's a quad. So keep that in mind. All right, which of the following statements on number 15 is not true? This is a supporting standard as well. Not true. And keep in mind, they may not have the word not capitalized, so you're just going to have to catch that and circle it and underline it and say, okay, this is a not true. That's what I'm looking for. But if you look at every answer choice, you're going to catch that mistake that you might make. Looking for not true. All triangles are similar to each other. Oh, gee, I don't know. That doesn't look like that one, so no. Similar means same shape, but not the same size. All squares are similar to each other. Same shape, but not the same size. I think that's a true statement. Oh, that is a true statement. We're looking for not true. That's right. All circles are similar to each other. Yes, if all perfect circles, they may be different sizes, but they're all the same shape. So that is a true statement too. So that's true. All triangles are similar. That's not true. I just proved that. So this one I think is my answer. And then D, all semicircles are similar to each other. Well, just like the circles, it doesn't matter if the circles are different sizes. Similar just means they're proportional. The same shape, not the same size. So my answer is going to be A, because that was the only one that is not true. So draw. Go ahead and draw things out here that help you prove these things or not prove them. So that will help. All right, number 16 says, which table shows the ordered pairs on the line graph shown below? Please don't miss something as simple as this. Let's just figure out which ones are which. And I believe that this is a supporting standard. So you should have already mastered coordinate plane. So when x is a -4, is y a -5? No, that's not on here. Immediately get rid of A. When x is a -5, -4, that's on there. -3, -2, that's on there. -1, 0, that's on there. 1, 2, that's on there. So I'm thinking that might be, from my screen, I can't see the last one, but so far so good. Let's look at C. When x is -5, it's not a -5, so that's not it. And then on D, -5, -4, yes. -2, -3, no. So that's not it either. I know my answer is B. I don't even have to see the last one. I proved the other ones are not. So go through each one. This one wasn't. This one wasn't. This one wasn't. That one was. So please make sure you can put a happy face on the ones that you have looked at every answer choice and you know for sure you chose the best answer. Make sure you know that on a coordinate plane, it's X first, then the Y. X comes before Y in the alphabet. So it's always X. Here's your X-axis. This is your Y-axis. So just don't forget that. Those are the easy ones. Number 17. What will the new coordinates of point J be if the point is translated 5 units to the right and 4 units up? All right, so point J, we're going to go 5 to the right and 4 up. 1, 2, 3, 4, 5. 1, 2, 3, 4. There's going to be our new J, and that is going to be at 9, 9. And then I'm going to go back over here to my answers and choose my answer. So don't miss the translations. Translation is just a slide, and they're usually just going to ask you about one specific point. So just deal with that one specific point and make sure you're going in the right direction. And yep, to the right and up. The other ones just don't make sense. If you're going to the right and up, the other ones just don't make sense. Look at those other answer choices just to be sure. All right, number 18, this is another supporting standard. Which net, when folded, will form a square pyramid? Now remember, pyramid means the sides are triangles, and there's going to be 4 in this case because I have a square base. So 4 triangles and a square base, that is A. This is a triangular pyramid. This looks like a rectangular prism, and this looks like a cylinder. So don't miss that one. Make sure you know your shapes, your 3-dimensional shapes. All right, number 19. Kristen has a triangular herb garden. The dimensions of the garden are shown below. Each herb plant needs 1 square foot of room to grow. How many herbs can she plant in her garden? So this is an area problem. Need to know the inside. How much room does she have to grow this? Now I have a base of 9 and a height of 4. First thing I'm going to do is look up area of a triangle on the formula chart. It's 1/2 base times height, or base times height divided by 2. So I take 9 times 4 and divide by 2. That's going to be 36 divided by 2. That is 18 square feet. So it says how many herbs can she plant? It says each herb plant needs 1 square foot, so she can plant 18 herbs. Now be real careful about what you're going back to. Now you found the area, but what if this said needs 2 square feet to grow? So then you could only say she could only do 9. But if she just needs 1 square foot for each one, then we're good with 18. All right, next problem. And number 19 is a readiness standard. You've got to know area of your shapes, but use that formula chart. All right, number 20. For exercise, Megan skates once around the rectangular block where she lives every day after school. If the block is 240 feet on one side and 180 feet on the other, how far does she skate each day? It says she skates 1 time around the rectangular block. So we're really looking for perimeter. This is a perimeter problem, and that means all the way around. So we're not just going to count those 2 sides where I see numbers. This is going to be 240. And this is going to be 180, so then we're going to add all of those. So I could do 240 twice and 180 twice. The 180 twice is 360, 240 twice is 480, and I combine those, and I get 840 feet she's skating around. All right, make sure you can identify what measurement we're performing and label it. Use that shape, use those diagrams, label. Draw pictures, write notes. Number 21, is, number 20, by the way, is a readiness standard. 21 is a supporting standard. To prepare for an experiment, students were asked to stack sugar cubes. So how many sugar cubes are stacked here? This is looking at a three-dimensional figure in a two-dimensional surface on the paper. I can count, this is the top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 on top. That means there's 10 underneath. That means there's 20 cubes. So make sure you can understand what is going on with that three-dimensional object. We're not going to count all the different squares there. Those are cubes. All right. 21 was supporting. 22 is also supporting. It says, at the end of the summer, Mr. Morgenstern drained the pool in his backyard. You see the diagram of the pool, 8 feet deep, 40 feet long, 15 wide. How many cubic feet of water will it take to refill the pool? This is a volume problem. And what does that pool look like? It looks like it's a rectangular prism. It's just a basic rectangular prism shape. So we're looking for volume of a rectangular prism. So V equals big BH. And what does big B mean? It's the area of the base. Please don't forget that. Area of the base. You may want to write that down as soon as you get your test and you have your formula chart. Go to the formula chart and write down. B is area of the base. And the base here is 40 by 15. So length times width times height. So 40 times 15, and then the height was 8. So that's what I'm going to solve to find my volume. We're going to use the formula. $600 and then multiply by 8. That gives me 4,800. And that's my answer. Use the formula for volume. Make sure you know what shape it is. Write it down. Tell me what the base is, a rectangle, so it's length times width. And use that formula and follow all the way through. All right. Moving on to number 23. Miss Hinderleiter is taking her class on a picnic. Each student is allowed to choose between a tuna or cheese sandwich, between juice or milk, and between a pear or an apple or an orange. Which table below shows all possible outcomes. So if there's 2 kinds of sandwiches, 2 juice or 2 drinks, and 3 fruits, 2 times 2 times 3 is 12. I should have 12 possible outcomes. So we're looking at our sample space here. What's our sample space? So I know there's not 12 here. That can't be all of them. I'm going to have to shrink this down probably to see this. Let's see. Tuna juice pear, tuna juice apple, tuna juice orange. Tuna milk pear, tuna milk apple, tuna milk orange. Yes. Cheese juice pear, cheese juice apple, cheese juice orange. Cheese milk pear, cheese milk apple, cheese milk orange. Yes, I'm going to say C. I don't even see B and D, but I know that's my sample space. There are 12 outcomes there, and I could do a tree diagram with either a tuna sandwich or a cheese sandwich with milk or juice, and then pear, apple, orange. So I could do that for each one. And I know there's going to be 6 there with the tuna sandwich, or 6 with the cheese sandwich. So look at all of them. This obviously doesn't have all of them right here. And then let's see what's wrong with the letter D. Oh, we're missing some juices here. So we've got a milk and an apple, and milk and an orange. We have that duplicated. So, nope and no. All right, that's a supporting standard on 23. All right, number 24. The graph below shows the relative number of earthworms found in ordinary moist soil. Number of earthworms on the left, depth of the soil in inches. So it looks like around 6 inches is good. I'm just looking at it. It says, which of these can be concluded from the graph? What can I conclude from the graph? No assumptions, just looking at the graph. It says the deeper you go beneath the ground, the more earthworms you'll find. Well, that's not necessarily true. I can go deeper here, but I have more at 6, so that doesn't really ring true. More earthworms are found closer to the surface? Not really. That's not concluded here. The most earthworms are found between 4 and 6 inches beneath the surface? Yes, that would be a true statement, but I'm going to try D just to be sure. The most earthworms are found either within 2 inches of the surface or more than 6, so that would be here or here. I can't say that's necessarily true. Let's see, this would be 35, this is 25, this is 20, 45, that's 80. The most earthworms are found either, I'd say no. So C is going to be my answer. All right. I will pick up with number 25 with the next video. So catch me there.